Okay, reviewing Module 5, Math 1010 Intermediate Algebra, Lesson 5.3. The first objective, and the only objective, simplify complex rational expressions. There are two basic techniques. One is adding fractions and inverting and multiplying, and the other is multiplying the entire fraction by 1. I will show the multiply by 1 technique on this first example. So notice the x and the y. The common denominator of all of those would be xy. So I could multiply the top by xy, come on, there we go, and the bottom by xy, and then distribute. The effect of that will be to multiply this by an xy, multiply so it's on top, this one by an xy, this one by an xy, oops, and this one by an xy. Okay, wow. All right. So on this one, the x reduces, leaving us 2y. On this one, the y reduces, leaving us plus 3x. Down here, the x reduces, and 3y. And here, the y reduces, and minus 2x. And that's it. Not much to do. So this is multiplying every term on the top and the bottom by the same common denominator, leaves the expression equivalent and just simplified. All right, the next example, if you have a full fraction, not two separate terms, but one term on the top and one term on the bottom, you can just change this. Essentially what we're looking at is this. In a different form. So we can change that to multiplication. So in other words, when you're dividing by one fraction, you can choose to invert and multiply instead. Now, oops, this looks a lot like previous problems that have already been reviewed. There we go. And that's at times. Oh, divide. All sorts of fun things happen when I use that eraser. Here we go. So we can factor everywhere we can. For example, I'm going to have to get that in a minute. This is a difference of squares. So we can pull out a k minus 6, k plus 6. That reduces, leaving our final answer of 3 divided by k minus 6. All right, I hope this helped. Let's take a look at the next example. All right, example 3 has negative exponents. Now the key to understand this, oops, that was different. It's recording still. Okay, good. Is x to the negative 5th is 1 over x to the 5th. So locally, that little bit can be changed to 1 over x to the 5th. Plus, same, but with y. Denominator, 1 over x plus 1 over y. So all of these changes are just local changes. Within these little circles, we're changing the negative exponents to a fraction. Now it's important that you don't try to put this x to the 5th all the way in the denominator of the larger fraction, because that's not where it ends up going, as you will see when we simplify this problem. Okay, so now I'm going to choose to multiply by the common denominator of x to the 5th, y to the 5th on top, both terms, and on the bottom, both terms. And you will notice something different reduces out of each one. That's why it's important to write them each time rather than try to do it in your head. So we now have our final answer of y to the 5th plus x to the fifth in the numerator, and x to the fourth, y to the fifth, plus x to the fifth, y to the fourth in the denominator. Okay, let's take a look at the next example for more negative exponents. So locally, that little x to the negative 2, that is 1 over x squared. Minus, now this one is a little bit different, because the 49 does not have a negative exponent. In fact, it has an invisible 1. It's positive, so it stays on top. And the y squared is the only thing that drops to the bottom. If you wanted the 49 to drop to the bottom as well, it would have to be in parentheses. Like that would make the 49 also drop to the bottom. It would also get squared and be huge, so I'm glad it didn't. Denominator, that's just 4y minus 28x. It doesn't have any negative exponents. So that denominator can all be written over 1. So this I'm going to do the different approach. I'm going to add these, well, subtract these fractions to make one fraction, and then do the invert and multiply. So first off, I need a y squared on this one and an x squared on this one, and that will end up giving me, in the numerator, y squared minus 49x squared over x squared y squared divided by 4y minus 28x over 1. Okay, now we can invert and multiply. That's the point of getting one fraction on top and one fraction on bottom, so you can invert and multiply instead of this divide. So now what I see is we need to factor. So y squared minus 49x squared, that's a difference of square. That's y plus 7x and y minus 7x over the x squared y squared times 1 over, now here we can factor out the 4 and y minus 7x. Now we see a little reduction. Not a lot, but enough to have to look. And that's not 1 on the top. Please don't erase anything else. Oh, it did. It's erasing all sorts of things when I do that. Like that times and that times. So we have y plus 7x. And in the denominator, the 4 will go first. 4x squared y squared. Double check the answer. Perfect. So make sure that you don't drop a coefficient down if you have a negative exponent, unless that's in parentheses all to the negative exponent. That's why this 49 stayed on the top. All right, example 5. On this problem, I would recognize the common denominator of 3r minus 1. It's a simple one. And then I'd multiply each term on the top and each term on the bottom by that. And the effect of that will be to reduce the little mini fractions, leaving us just 5. Here I'm going to distribute that minus 5, so it's minus 15r and plus 5 on the top, and 5, and distribute the positive 5 on the bottom, plus 15r minus 5. And we see some common terms. 5 and 5 is 10, minus 15r, and 5 minus 5 reduces, that's just 15r. And now we can factor. We have to factor to see if we can reduce. I can pull out a 5 in the numerator, leaving me 2 minus 3r. And on the bottom, I can change the 15 to 5 times 3r and reduce the 5. Final answer, 2 minus 3r over 3r. And you might think, hey, why don't we reduce those? This is factor, that's great. This is a term. Terms don't reduce. That's the same thing up here. Why don't we just reduce that r? No, 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 no. Why don't we reduce the fit? No, no, no. You have to factor, and then that's a factor of 1. That is not a factor of 1 because it's 2 minus 3r on the top. If you had another 2 minus 3r, you could reduce. But without one, it is reduced. All right, that completes that lesson.